Welcome to the webinar Implementing MCP Servers with OpenEdge. So in this webinar, I want to give you some background on how AI works, how large language models work, how AI agents work, and in particular, how MCP servers can be used to integrate our own applications. Before I start diving the actual topic, let me talk a little bit about my personal experience with AI in general. Well, I refer to myself as a software architect, not a data scientist, and I don't really have ambitions to become a data scientist. The experience that I've made in the last couple of months is that with the state where we are with AIs and tools around AIs and commercial or open source offerings from various vendors, it's generally enough to have a good understanding of how AI works, but for most use cases, it isn't really required anymore to become a data scientist to do something with AI, which is quite good. I've started playing with tools like ChatGPT at the end of 2022 when it was released to the public. I started here and there integrating AI with our applications, our framework, but I really only started deep diving into that whole topic earlier this year. And as I said, I have no ambitions to become a data scientist or anything like that. So yeah, my background, I'm an OpenEdge programmer, architect since 35 years now. Started with version 5. And in the longest period of that time, supported companies developing OpenEdge in various aspects of application modernization, implementation of features of latest OpenEdge releases or new technology trends. At Consulting Werk, I'm running the business, but I'm also still involved in our customer projects as a architect for modernization questions. I'm taking care of our product development as a product manager, lead architect, etc., etc. Well, we at Consulting Werk, we help our customers to modernize OpenEdge applications. We believe we have a very deep technical expertise in that field. I have many colleagues which have 20 plus years of experience in OpenEdge. If just a little bit under 20 years, we might still refer to these colleagues as a junior in our team. We are present in various countries in Europe with presence in the United States, and we're working with customers almost all around the world. And besides the consulting service that we provide, we deliver tools and solutions to our customers. So today's topic, the MCP standard. MCP is very often referred to as the USB-C standard for AI because it's a universal protocol that basically lets you plug various applications into all kinds of AI agents and large language models, and it all magically works together. MCP is a relatively young standard. It was released by a company called Entropic in November last year. So in less than a year, it has become one of the driving forces of AI-based integrations between applications and large language models. Quite impressive. So before talking about the company that released the MCP standard, I'm going to talk a little about OpenAI, the company that started in artificial intelligence, I think, for the broader public. OpenAI is a research company out of California. It's a vendor of ChatGPT, which was released to public in November 22. And they're a provider of various large language models. A large language model is a service and that's actually the core of artificial intelligence. Large language models typically understand natural language or various data formats, text, images, audio, whatever. And large language models are enabling us to interact with computer programs in a completely different way. We don't need a classic UI anymore. We can just speak in our language or type in our language, and the LLMs are able to turn that into requests and process the responses into and from software systems. When OpenAI introduced ChatGPT, they basically defined the standard for how the network protocol, the REST protocol typically looks like that applications use to communicate to a large language model. So they've been have had a very huge influence there. Not all LLMs exactly use the same interface. So Claude from Anthropic or others do things slightly different, but in the core, very, very similar. And one of these terms that probably many people use, and maybe not everybody really knows what it's about, it's a GPT. GPT stands for generative, so it can generate data. It is pre-trained, so it has some knowledge, some specialization on aspect. Yeah, and it transforms input data prompt very often into an output. So they are the type of the LLMs, the large language models that are widely used for generative AI and chatbots. Large language models are very, very common. They're very large. You can use a large language model for asking it questions about normal life, but they also have understanding about software and various special knowledges, and so can answer questions in that area. Large language models are large in the data that they're based on. It's really a huge pile of information of words in different languages and how they have meaning with each other and how they belong to each other, synonyms and stuff like that. And a large part of the algorithm that's implemented in large language models, it's just probability. Somebody asks you a question and they look for what is the most probable combination of words or letters to formulate a response. Based on deep learning, and with that they just optimize the data so that it's very fast queryable. Large language models are typically so large that almost nobody would be able to host them at home. They require lots of memory, lots of RAM. So they're typically hosted in the cloud and used as cloud services. They're stateless. They don't remember anything about the requests that you do to them. Adding this memory, that is one of the tasks of an AI agent. So OpenAI has applied this generative pre-training architecture in a GPT-1 model 3 years before, or 4 years before they then released ChatGPT based on their 3.5 model. We're currently having a model version 5.0 or 5.1. It's very difficult when you're getting into all these AI to keep up with all those models. It's like every week there's a new greatest and best and fastest model to choose from different vendors. Yeah, it requires some reading about what the specialties are of those, and at the end also some try out whether they're good for your actual use case. So these GPTs are typically used to generate text data, but they can also be trained to generate other data. Some of them have a feature called reasoning. That is a feature where the large language models basically start by analyzing what the user, could be a human or another computer system, wants from them, and making a strategy about what would be the best way to solve that problem. Sounds a little bit like real thinking. You have a question and you think about, okay, well, can I answer that spontaneously, or do I need to separate into different smaller pieces? And yeah, well, in the end, these systems are still being built to simulate many aspects of human thinking. So then agents as a next component. So agents are basically also software programs that connect users with the LLM and tools. Um, an LLM works on prompts, requests, and an agent typically accepts a prompt from a user. It could be a coding task, or it could be a everyday question. Could be a question to get data about customers, whatever. And one of the standards that OpenAI has defined with their GPTs and all the others are following, there's a distinction between the user prompt, what the user wants now, and the system prompt. The system prompt basically configures the LLM and what kind of responses are expected. That can start with languages. It can start with giving it some information about the knowledge level of the users, and also a little bit about the tone, whether it should be more friendly or more cold and neutral, whatever. And with this prompting, LLMs would basically only be able to make decisions, provide answers based on the data that they've been trained on. This data that they've been trained on, that's always data that has a certain age, because when an LLM is released to public, its learning process is widely completed, and it certainly isn't trained on data that is sitting in our ERP database or in our OpenEdge database or other stuff. It doesn't know anything about what happened yesterday or today because it was trained weeks ago. So in there, different aspects or different techniques can be used to close this knowledge gap to the AI. And one of them is providing of tools. The other aspect is RAG, retrieval augmented generation. Both are ways how an AI agent can provide additional information together with a prompt to the large language model, so that the large language model then has all the data that it needs to provide us with an answer. Especially these tools, that's something that we are looking into, because tools has been adopted into the MCP protocol and is a way how the LLM actually can decide to start a query into our application. LLMs are stateless services, typically accessed via REST, and an LLM doesn't remember what I just did with it a minute ago or last week or 2 weeks ago. So when ChatGPT or Claude or other websites that form an AI agent remember what I asked the LLM a minute ago or yesterday or the week before, then these websites, they are having these agentic features and they can add memory to it, and before they call into the LLM, decide which of the memory of what I did recently or a little bit further in the past with the LLM is relevant for the question and can provide that to the LLM. So, like I said before, keeping up with the LLMs and their strengths and their performance and their cost, it's really a science of its own. A little bit try and error and yeah, reading current IT newspapers, etc. So here as a diagram, so the data that goes into a request to the large language model, the system prompt where we tell it at what kind of a person or what kind of system the LLM should react. Then the user prompt, what the user wants. The user wants to have the credit limit of Lyft tours here. Then the agent can provide previous prompts and the responses to that. That's how the LLM knows maybe You ask a question to the LLM came back with a question to you, and you answer that question, then it's absolutely required for the LLM to know the history of the very recent prompts, but it's always part of the request. It's never stored in the LLM. And a list of tools. The agent can implement these tools, and the agent introduces these tools with a request to the large language model. And based on that, the large language model can decide to return a response to the agent saying, hey, I'm not yet ready to give the user the answer, but in order to enable me to give the user the correct answer, please execute this tool. So again, in written form, this definition of tools or this implementation of tools was already there in one of the early versions of the GPT LLMs by OpenAI, and has been adopted in a very similar way by different vendors of LLMs. Similar in software architecture is always a problem, because similar means, well, there are differences. It's not 100% compatible. And that's where Anthropic came to the table. Anthropic is basically a competitor of OpenAI. It's another company that provides a website, chatbot, agent, and their own large language models. Anthropic is focusing also a lot on developer tools. Yeah, they're also based in the US, founded by some former OpenAI members. So there's some joint roots. And their tools are typically called Claude as a chatbot, also known as their large language models. So they're naming their large language models basically after a form of a poem. So, and they've introduced the Model Context Protocol, MCP. So the Model Context Protocol is a protocol for providing context to the large language models. So an open standard introduced by Anthropic in November last year, and they just want to standardize how AI systems integrate and share data with external tools, systems, and data sources. It's a universal interface for reading files, executing functions, handling contextual prompts, etc., etc. And it was widely adopted by all the major AI players, including OpenAI and Google. They did this because they felt that, well, if everybody has the same thing, just similar, we're going to end up having an end-to-end integration problem. Like really, each application that wants to integrate with everybody needs to look at how that is implemented there. So that's why they've introduced a standard. It's based on JSON RPC. It specifies standard I/O for MCP servers that run locally, or HTTP as the transport mechanisms. And the data format is typically JSON. The nice thing is, when implementing MCP servers, you don't need to know that much about how it's technically implemented, because there are rich SDKs that are typically used. So MCP is then basically an alternative to RAG. The difference between RAG and MCP is with RAG, retrieval augmented generation, the agent decides before calling the LLM which data might be relevant. RAG is typically used for large collections of text unstructured data. Tools calling is typically calling to structured data. MCP also has a way of providing resources which can provide data in a similar way than RAG. There's a huge overlap in how MCP and RAG can be used to provide relevant data into the AI agents. MCP defines three types of integrations. Prompts are basically templates, samples for requests that users can make to the system. These prompts can be very helpful to provide really guidance and reusability on certain workflows that just work well with the system that we're interacting with. Resources are data from files, databases, or whatever that we provide in the LLM, and tools are functions that allow the model to take action, interacting with an API, and this API could be connecting to an OpenEdge app server to retrieve data or update data in a database. So the MCP tool flow is when the agent on the left-hand side, there's a guy with the headset there, makes a request. It provides basically the question of the user. Show me the credit limit of customer lift tours, please. Available tools. I do have a tool, get customer details. If you find that helpful for answering this query, then let me know and I'll call get customer details. So the LLM might come back with saying, yes, okay, please do this tool call. Makes a request to call the tool, get customer details, and provides then input parameters. In this case, it has identified that lift tours is probably the name of the customer, and that would be the input to the query. Then the agent can call into the MCP tool, and in this sample now, the MCP tool is making a request to an OpenEdge app server, running a get customer details procedure there and passing the lift tours as an input parameter. The app server will give some sort of response. I found the customer, here are the details, I found multiple customers, or I found no customers, or maybe even a technical error that the execution of the procedure failed for whatever reasons. And then the agent gets back into the large language model, repeating the prompt and basically returning that now it has got the response to the tools call. So the get customer details tools call returned all the details of the customer, typically as a JSON object. Doesn't need to be JSON, could also be any other form of text that has some structure. Typically, it's JSON or some form of markdown. But when writing business applications and trying to debug systems or writing unit tests, we find it very useful to provide JSON responses, because then we can unit test the MCP server code much easier than having to pass a lesser structured form of text data. So after the agent has made the follow-up call into the large language model, the large language model ideally is then able to provide an answer to the user, like the credit limit of the customer lift tours is $12345. Basically formatting the data from the tools call. There could be multiple tools calls. If the LLM knows it has one tool to search a customer by various arguments and then another to provide all the details, then it could also be that this sequence between agent or this ping pong between agent on the one side and LLM on the other side has multiple back and forth iterations. So MCP is a client-server protocol. Basically, the client being the agent, or in a bit more abstract way, the LLM. It's just another API type. It's very often compared with Open API and Swagger. For the actual communication, it can use standard I/O for local HTTP servers, so servers that run on the same machine as the agent, or based on HTTP or WebSockets, HTTP 2.0 typically. And there are various SDKs for developing MCP servers. As everything in AI seems to be based or starts with Python, Python being a language that's very popular in the scientific field. So it's a language used by many data scientists, and so it gained a lot of relevance in the AI space, but it's not the only alternative. Python is easy to read, and it's also not impossible to maintain. It's not my favorite language, to be honest, but I can fight my way through Python with the help of some AI coding assistants. As usual, you can implement everything also in Node.js. So there's an SDK to build MCP servers in Node.js. Microsoft has released an SDK to build MCP servers using .NET. There are Java SDKs, there are SDKs in various technologies. There's no SDK yet to build MCP servers in OpenEdge. Also, last week at the American PAC Challenge, Progress has announced that they're looking into that. Yeah, I'm curious to see what will be the results that Progress provides there. When dealing with MCP servers, sooner or later, you want to be using the MCP inspector. The MCP inspector is basically a test tool for MCP servers, or it's like the Swagger. When you're building REST services or consuming REST services, then the Swagger tools or the Open API tools are typically your first stop to try to interact with an API, with an endpoint that you use. The same can be done with the MCP inspector for MCP servers. And the MCP inspector really lists the tools that are provided by the MCP server, allows you to interact with resources or shows the prompts which are there, and you can make sample requests there. So let's quickly dive into it. So I'm starting the MCP inspector by copying this into a command line. npx is basically a tool that downloads a Node.js package and runs it on the fly without installing it. And it's now opening the website. And if I now populate the data which I found in the documentation of Atlassian, then I'm making now a connection to the MCP server provided by Atlassian for interacting with Jira. So I'm now connected to that. I can see a list of tools. And for instance, with that, I can now make a request to get details about a Jira issue in the same way as an LLM could do. One of the arguments that I need is the URL of the Jira, so that it knows which Jira instance it is. I'm copying that out of my browser. And then the next one would be an ID of a ticket. And then I can execute this tool. And now I believe see a JSON data with the details about this Jira ticket. And in that same way, an AI would be able to make calls to this. And the key bit here is that the tools have a human readable description in natural language. And based on this description in natural language, and the same is true for the arguments, they also have natural language description. Based on this natural language, the LLM will decide if for the current request, this tool would be helpful. So if I go into an AI agent, it's configured to use this MCP server, and I make a query, show me the assignee of Jira ticket SCL 4990. The LLM will interpret my request, my prompt, will interpret the list of tools which have been registered by the MCP server, and then will say, oh, great, I'm not able to answer the question about the details of this ticket, but I have an MCP server tool that can. So when you want to implement your own MCP server, you barely pick one of the SDKs which are there. And you should really just pick the one of the language or the development environment that you feel most comfortable with, or the one that fits better into your deployment architecture. I've chosen .NET here. .NET or Microsoft provides their SDK on this website. It's all based on .NET Core, so it's not limiting us to Windows. It works on Linux exactly the same way. .NET does not require the Visual Studio anymore. .NET comes with the .NET command line utility, and .NET also supports running applications from source code. So compared to where .NET was like 10 years ago, classically with everything in Visual Studio, Windows only, everything needs to be compiled, heavy focus on their tools. In the way you work with .NET applications, there isn't a huge difference anymore compared to working with Node.js and NPM and the like. The relevance of command line tooling and the flexibility that it gives us is there too. And basically, the steps to start building an MCP server using the .NET SDK is you need to install. The assumption is you have installed the .NET SDK on your PC. That is a requirement, but then you need to install the templates for the MCP server using this command line utility .NET new install Microsoft extensions AI templates. Then you create a new project based on the MCP server template. That's the first argument after the new. And with the -n, you give the new project a name, my MCP server sample, and then you could run it straight away without ever using Microsoft Visual Studio. You can edit the code in a basic editor like VI or in Visual Studio Code or in the actual Visual Studio. All that doesn't matter as long as it's valid C# source code. And then you start implementing into basically the skeleton that has been generated by the comments that I've shown you there. You start implementing tools. And tools are just very basic C# methods in classes. They are annotated with this MCP server tool annotation, and C# annotations are in square brackets, not with the @ sign as in the ABL. And you provide the description both for the methods and for the parameters, because that provides the context for the LLM to decide when this tool would be helpful for the current tasks. So we can look into that briefly. Where's my Visual Studio there? So this is my sample MCP server project here. We have a program where we basically just do some initialization, where we look at start parameters that tell me whether I'm providing an URL to pass OE. Otherwise, I'm assuming a default one. We have a configuration for an authentication key. That's something I'll talk about later. And then the standard initialization here just says, okay, we are launching this as an MCP server with the standard IO server transport. So this is a command line utility. The alternative would be to implement an ASP.NET web service, which implements then an HTTP-based transport. And all the tools which are found in this class should be exposed as MCP servers. So if you then look into this class, there are 4 methods right now. What these programs do here, they use the Open Client Toolkit from Progress to make a connection to the app server. The Open Client Toolkit from Progress is something which is there since basically version 9, but since OpenEdge 10, so way over 20 years. Open Client Toolkit can make connections from .NET applications. So this is basically making the connection, and that's calling into a procedure on the app server. So all the logic is implemented on the OpenEdge app server. I'm just using the .NET MCP server to implement the actual API standard. So for interacting with OpenEdge, there are basically 2 variants One is using the app server through Open Client, or I could also implement REST services or use Web Handler, whatever fits me best. I could also launch when a request comes in a batch client session and interact with that. I think that depends on which way you choose on both the actual use case, but it may also have some implications about licenses. Because the app server is typically the license that allows you to make remote calls into logic and not the batch client. The batch client might be an implementation, but whether that actually licenses you to do something like that is a different question. So that's why I think we should be using app server here. It's pre-started, pre-configured, ready to use. Should also be faster when the load is heavy than batch sessions. So the .NET Open Client Toolkit is really a tool that builds an .NET assembly that knows how to access ABL procedures on the app server. It does not translate ABL code into .NET. It's really just enabling to make .NET applications calling into the app server. The .NET Open Client Toolkit is there since OpenEdge 10, and .NET Core support is there since OpenEdge 12a. Again, the .NET Core support is required so that we can do the stuff that I'm doing here, not only on Windows, but also with using Linux as a backend. Running .NET on Linux is very lightweight. And running .NET Core on Linux is very lightweight. Yeah. The .NET Open Client Toolkit comes with a nice little Java UI, command line utility, or a command line utility to build or rebuild the proxies. This nice little Java GUI that looks very funny if you're running that on a 32 or 38-inch large screen, because it really just doesn't scale and the screen resolution. But you don't need it that often. You build the proxies. The proxies need to be regenerated whenever you add parameters or add fields to temp tables, etc., or add new procedures to the proxies. You don't have to regenerate the proxies each time the .p files which are called are changed. So that's basically how the proxy tool looks like. You create a proxy resource or so-called app object. Then you add progress procedures to this app object. Then you hit the build button. That's this molecule button in the toolbar. It comes up with this dialog. Then you provide basically the name, the namespace, the location where it should generate the proxy, the client type. I've chosen here .NET because it needs to fit to the MCP client SDK that I'm using there. Yeah, some specials about how to deal with null values and errors and return values, etc. But not a lot. So and then what happens is this Open Client Toolkit basically generates C# source code. The C# source code makes use of a progress library that implements the AppServer protocol, and based on that, can call into our procedures. Our .p files are exposed as methods on this proxy object. So let's quickly jump into this again. So basically here I'm creating an instance of this app object that I generated in this tool, and this get customer details is basically calling into an OpenEdge procedure. But look at the OpenEdge procedure here. The procedure has 3 input and 1 output parameter here, an authentication key, customer number, and the name of a customer, and a response is returned as a long char. Yeah, then we implement logic here. We check whether a customer number is provided or a name is provided. One of the two needs to be provided. If not, our response is an error message. And this error message would be handed through from the OpenEdge procedure, the Open Client proxy into the MCP server method, and then returned by the agent to the LLM, and then the LLM can tell you that, hey, one of the two need to be provided. In this procedure, we're now using our business entities, which is component of our developer framework. But I could really just also do a very simple find in the database and see whether the record exists. And when it exists, then we either provide, or when multiple records exist matching with a name, we return a list of customers. If just one exists, then we return all the fields of that. So that is basically the implementation of the data retrieval and business logic. I have an update procedure that I will be showing soon. In the update procedure, I'm taking the customer number and I have parameters for the various fields that I want to enable to update. We could also be receiving a JSON object, but just like a handful of fields that we want to update, it's actually quite straightforward to, or easier to have the simple parameters. We find the record. If it's not there, then we return an error message. If it's there, then we update the various fields through an OO interface into our business entities, call save changes. If save changes throws a validation error, then that would be caught in a catch block that we have in this include file. Otherwise, we return the status that this has been successfully implemented. So now let's test this in the MCP test tool. So I'm closing that one that I launched earlier. Calling the MCP inspector provided by Anthropic. I called it from a batch file because that's now providing all the parameters that it's standard IO. This is the name of the executable that I'm running. The .NET exe provides the URL to my PassOE, and it provides an authentication key that I'll talk about in a bit. So when I connect to this MCP server, the MCP inspector now has basically launched my .NET executable, and I can list the tools, and that now shows me what is there. So we have a tool, get customer details, which I can use to either provide a customer number, and then I run that, and I get a JSON object with the various fields of the customer, or I can use a customer name, and if there's only one customer, I get the details too. If I use a naming pattern that returns multiple one, then this tool returns a list of customers. We have an update customer details tool with a description, and I say I want to update customer number 2, and I want to set the email address to info@does-not-exist, and execute this tool, and then basically the response I get is invalid email address. That is now an error message which is returned by the business entity. So that's one of the reasons why I'm using business entities in our framework and not duplicating the database access. I'm not seeing any of the validation here. The validation is reused and it's actually implementing the same validation that users would have to deal with if they're running any standard UI or front end to that. Good. So I can now very easily integrate this, I started that already, no, into an AI chatbot like Claude. This could now also be the desktop version of ChatGPT. We switch it to English. So, and I could now just ask it questions like, show me the credit limit of customer lift tours.
Mike, there's a question if this can be combined, so multiple MCPs into one single call.
Well, they would be executed one after the other. But yes, so they can, and funny, we actually see that here. So I said, show me the credit limit of Lyft tours, and the response that the MCP gave was this customer isn't there. And then the LLM tried, okay, well, then let's try something else. Do we find somebody that's similar? So it looked for one where the name matches Lyft. And then it said, okay, I found Lyft line skiing, and returned the details of that one. So it has now done, out of one prompt, actually 3 requests into 2 tools in the end from the same MCP server. But if different MCP servers would be registered, or I have different MCP servers registered here. If I look into the setting here, I see that I have my Sports 2000 MCP server. I have a MCP server here for our developer framework with Atlassian there. So I can also ask, what is the description of Jira ticket SCL 494, and do that in the same interface. And I don't think that I can demo that right now, but if, for instance, in the customer record, there would be a reference to a Jira ticket, and you would be asking questions, so what is the most recent Jira ticket logged by customer Lyft tours? I'm confident that it would be doing the sequence of the multiple calls until it has a satisfying enough answer, also by playing ping pong between different MCP server tools. Yes. So I think the MCP server tools, they should be quite small and specialized on a certain tasks, and the LLM then should be smart enough to combine all the stuff together.
Yeah, there's a question which goes also into this direction. If there's anything for error handling in the MCP protocol, so like HTTP status codes, so that basically the LLM knows the result is good from the tool.
Well, there isn't an HTTP status per se, because the MCP protocol also works with local processes. But the one thing that took me a while to get into, the way how you interact or how these tools interact with each other, is natural language. And it parses natural language. So if my parse-OE would be down, the .NET Open Client would be throwing a .NET exception and basically returning the error message of the .NET exception, saying that it cannot connect to the app server. And the LLM then is smart enough to say, oh, there was a problem connecting to the backend. Maybe one of the systems is down, and it makes up an answer around the technical error message that's usually quite good. Let me show you this one, because it's basically the same stuff. So I say update the email address of customer 4 to something bad. I'm using this because we have validation in the system that the email address is syntactically correct, and syntactically correct means you need to have a domain and a top-level domain. I'm missing the top-level domain here, and we can actually look up the mail server if it's really a valid domain. So the MCP server will be called, but the response from the backend, from whatever layer, I mean, that could be coming from the ABL procedure, it could be from the open client, it could be from anywhere in between. The naked answer we get is invalid email address, and it's turning that into a friendly message here. This update failed because something bad is not a valid email address. So this bit here about the system requires a properly formatted email address, that comes out of the knowledge in the large language model, because the large language model does also have some understanding about um, about um, 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 well, yeah, about real-world concepts like email addresses or dates or whatever. When I now update a different field, update the country of customer needs the quotes. I also never told him that FI is Finland, but it just knows that FI is the code for Finland. Oops. That's now an implementation problem. It doesn't like the email address, which is in the existing record. It is now, my sample is a little bit too simple. So we have another procedure there, which allows us to more do free-form queries. So the get customer details API that we have implemented here as an MCP server either takes a customer number or name, and with a name it then tries to find one, and then it provides the details, or if more than one is found, it returns a list. But you can also do this. And now the LLM basically decides, okay, I need to create an ABL query string and pass that to the backend. So the request that goes to the backend is for each e-customer, which is a temp table in a business entity where the country is Finland. And the credit limit is greater equal 10,000 and less than 20,000. And then we get the list of that. And the sales rep is HXM. Now we see that my actual prompt was just saying, was very lousy, just saying, and the sales rep is HXM. And it has regardless turned that into a valid query string, which now added the sales rep HXM to this. And well, I haven't checked, but I'm assuming I'm getting a similar list of customers. And this is now also all just based on the description of the tool. If I look at the query customers tool, so the input argument is just the query string. The description of the tool that I have there, let me just add line breaks. I'm providing all the relevant information in this description. So it queries customers, and it's based on an ABL query string. So even though people might think, oh, all these LLMs, they don't know nothing about ABL because ABL is too much a niche technique, the latest LLMs know how to build valid ABL query strings. That's not a problem. The next thing that I then provide is the name of the table and the fields and all the data types that can be used in that query. And based on that, when I provide a credit limit with a space, it knows that in its description of the tool, it has credit limit without. And I would even assume that when I do this zip code, because the LLM should be able to translate zip code into postal code. So it turns that into integer of is probably not the right thing. So here we see the error flow. So the query was first provided with integer of postal code greater than that. And our query returned that it wasn't happy with that. I was expecting a different message. But then it tried it as a string comparison. So the LLM tries to correct errors by itself by making follow-up calls. Now we see we have customers that have zip codes in character matching because it's a character field between 10,000 and 20,000. If I want to have a different search implemented there, then I would be doing that on the OpenEdge side where I may have more knowledge about how to really filtering that. The LLMs are really smart in trying to do that themselves. And the other nice thing, if we now integrate it into real applications, most users would probably still be expecting to be working for many requests, many tasks in a classic application. That's now our Angular front end to an OpenEdge ABL backend application. And we do have here a chatbot implemented. The implementation of this chatbot itself is based on Node.js, because that was the tool of choice of our web developer here. What a surprise for a web developer, I would say. And he has integrated the MCP client SDK for Node.js that enables Node.js to call into MCP servers and interact with the large language model. And based on that, I can run the same. I was writing a for each. I don't want a for each. We're beyond for each. So show me all customers in Finland with a credit limit above 20,000. So, and it's doing this call too, and it's getting some customers here and returning as that to us in this list. And it also adds some additional data here. The highest credit limit belongs to Jess Futis Scopa with 96,200 euro dollar. With the currency, I think in my slides I was using dollars. Nobody tells which currency is used here, so we either should provide a currency as part of the response, or which currency money units are typically provided would also be something that we can provide with the system front to basically set the scene. So it's basically assuming that all numbers here, because I'm in Europe, are expressed in euros. And I can make the same interactions here than I'm doing in Claude. And as a matter of fact, in this agent sample here, in this chatbot sample here, I mean, we also are using an LLM. We tried it with GPT-5, works nicely. And this current configuration is using Claude Sonnet 4.5, which is actually the same LLM that we're using here in Claude's own AI agent tool. So with very little effort, you can start making your applications react to human language. Good. There's some aspects where it then gets a little bit trickier. One is authentication, and we're really having two layers where we may want to authenticate. If you want an actual authentication of the user who's using the agent, that's for instance implemented in Jira. When you're using the Jira MCP server for the first time, you basically have to authorize an API to use Jira on your behalf. It's based on an OAuth2 flow, and then the agent will store this JWT token that contains your user's identity along with a certain validity of that token. The agent will store that OAuth2 token for you, so that when the agent then makes the calls on your behalf to an MCP server that requires authentication, it provides that. For that, you need to have some OAuth2-based authentication mechanism, maybe Office 365 or Keycloak, whatever, and authenticate users that way. The other level of authentication is then, so once you get into the app server, do you actually need to know a user, or do you just need to know that the system is allowed to call into that app server? And in my case, I've implemented an authentication for the systems. So when we start the MCP server process, we provide an authentication key. And with this authentication key, we are expecting a character value, and the value that we have here, we're using the encryption methods that are provided as part of OpenEdge in the ABL. And actually, as part of the authentication key, we have a username, an encrypted password, and a login company. And then the MCP process operates or makes app server calls based on that identity. And then within the application or the application framework, we're then able to decide which calls are valid or are authenticated and authorized by that user. And the other aspect that may come relevant, I've been using here in my demo now the desktop application of Claude. There's also a desktop application of ChatGPT. Many of these agents have desktop applications because it may make it easier to integrate. But if you want to use this with an AI agent or chatbot that is running somewhere in the cloud, then you need to have a solution how either the cloud can reach your locally running MCP server, or how your remote running MCP server can reach your app server. And I see there two different scenarios. One is a developer that needs that ad hoc, and the other would be a real production environment. If it's for real production environment, then these developer tunnels are not the option. Then you need to look at real VPNs or deploy the backend also in the cloud and deal with network access there. But for developers, these developer tunnels, there are various solutions for that, and we ended up using two different ones for two different use cases to support calls from the cloud to a specific application, to a specific network port on your local developer PC. And the two solutions that we are using for this purpose, one is the Microsoft Developer Tunnel, the free service by Microsoft. You install this and then you run that, and then you basically get a host name, and under that host name, it will then forward all the calls to your local PC. You always start the developer tunnel from your local PC, so it's never something that just unattended and by surprise gets into your PC. Well, you probably have to have some trust that that's true. The other solution is the local tunnel. It's an npm library on GitHub. The reason why we deal with the two are different HTTP standards. At the end of the day, I mentioned trust a second ago. think I trust Microsoft a lot. My laptop's running Microsoft operating system. I'm doing most of my communication through Microsoft tools. So if Microsoft wants to do bad things with my data, they can do that anyway. But the Microsoft Dev Tunnel only supports HTTP1. HTTP1 is okay for exposing a PAS-OE to the outside world, but MCP servers require HTTP2. So that's why we're using the local tunnel, because that also supports HTTP2. So just some thoughts on that topic. I would recommend every developer, when opening tunnels to the outside, to first discuss it with management or IT. I do not see a huge security risk in using them, but I'm also not a security expert, to be honest. So I open the developer tunnels really when I need them when I'm doing active development and testing. And I certainly would not consider that being a solution to expose production environments that way. We use a development environment or developer tool in the cloud, Devin, which is providing AI-based developer tooling as a browser-based application running in the cloud. Devin also knows that it may need access to resources which are in the internal network. Devin actually supports an actual open VPN client. I think there's another VPN standard that they support. So it's a general requirement that developers working on connected applications may need to expose parts of their development services to cloud-based services. So that's not really something that's very exotic anymore. Good. Well, one very short product announcement. Most of you will know that we are a tool vendor, that when we're doing things like that, we very often think in terms of tools. So we are currently starting to build, doing lots of R&D and planning and conception a tool to make it very easy to expose OpenEdge logic as MCP servers. We will be making this available both for the use with and without the Smart Component Library developer framework. Our current thinking is that we will be following the annotation scheme, that we annotate procedures or methods of classes that will be exposed as the MCP tool, that we provide the description of the tools in the ABL code and not in the C# library. We really want to avoid that for building MCP servers. We will have to be writing both ABL code and .NET code. The .NET code really should be a generic solution that initializes itself based on a kind of like discovery call into the OpenEdge PAS-OE. And with that, we'll then also provide a solution for the authentication and authorization. We will really start with the actual development on that toolkit in mid-November after the PAC challenge. I don't think realistically we'll start before the conference. Yeah, and as soon as we have details, we'll announce them, and I assume that will be later this year. So with that, I'm coming to the end of this presentation. So we recently started our newsletter, the Smart Update newsletter, a couple of weeks ago. We plan to be releasing new editions of the newsletters every 2 or 3 months. If you want to subscribe to the newsletters, just look at this website or send us an email at marketing@consultingwerk.com, and we'll put you on the list of subscribers. Yeah, next events. The big next event is going to be the PAC challenge in a little under 4 weeks from now in Valencia in Spain, 5th to 7th of November there. We will be there as an exhibitor in the product expo. Various of my colleagues and myself will be doing lots of presentations. So if you haven't registered, I strongly recommend you to register for the conference and meet us there. Yeah, next webinars, we don't have dates yet, but we're working on that. Kind of like currently doing a series of these AI-focused webinars. We did 3 weeks ago one on using AI-based tooling to support the monetization of OpenEdge applications. The recording of that is on our YouTube channel. Well, this one was the MCP servers webinar. Probably at the end of November, we will do a webinar where we introduce how to build chatbots and integrate them with OpenEdge applications, both browser-based applications like the Angular application that I've showed there, but also how you can integrate chatbots into an OpenEdge GUI application. And then probably early next year or so, we'll do a webinar on AI coding and developer assistance. Current thinking is it's going to be around Windsurf and Devon. But if in the next 2 or 3 months we find a different set of AI developer tools better because it's a quickly changing market, then we might be talking about different tools, but current thinking is Windsurf and Devon. Well, and with that, Lutz, are there questions left?
You basically answered the only open question by accident. That was about how the MCP works with our Jira instance and how that is authenticating. You kind of touched that.
Okay. Yeah, so how the authentication with Jira there works is the first time you register the Jira MCP server with any of those agents. I can quickly show that's a config file still here. And typically all agents that support MCP servers have a config file like this. And there you then make an entry. You say, okay, I want to support the Atlassian MCP server. And these details about what command to run and which arguments they are, you can find them in the documentation from Atlassian. They can also remember some disabled tools. So as you see, I've disabled most of the conference tools here by enabling fewer tools in the agent. Well, the agent or the LLM have a lesser risk of picking the wrong tool for the job that you want. Plus, the more data that you put into the LLM with a call, the slower the LLM will be. So it's kind of also a tuning to really only provide what you need. And the first time you start the agent after you've registered such an MCP tool, then the Jira authentication page will show up, or the page to authenticate an API. So I didn't have to log on again, but you see the prompts. This is where basically Jira asks you, hey, do you want to? Your Jira account or your Atlassian account has access to 4 different Jira instances, our own one and Jira instance of customers. To which one do you want to authorize the access? And then I've chosen ours, and that returns then the OAuth2 token to the agent, and the agent stores that for us. And you'll have to rerun the flow once the OAuth2 token is expired, which is depend on Jira then, and that's how it works. So it typically works with either providing the OAuth2 token with this configuration. So might be an additional argument here, like what I do here. So here I have the OAuth key provided there, or through an OAuth2 authentication flow. Good. That was the only question. Then thanks for your time. Hope you found this useful, and hope to see you soon in Valencia or in one of our next webinars. Thank you.